Okay, I'm going to introduce myself now because we are missing the moderator for this. My name is Tobias Freudenreich. I'm graduated engineer for media technology, and I studied in Hamburg at University of Applied Sciences. And I'm going to tell you something about my diploma project today. This project was supported by Professor Dr. Eva Wilk, who unfortunately can't be here today. It's a very great pleasure for me to speak in front of the audience because I've been here at the last Tonmeistertagung at the 24th convention to seek sponsors for this project, and I was successful with that. And what you see there is one of the advertising actions I started to find sponsors here. Maybe if you've been here 2 years ago, you've seen these little cards with the misspelled domain of Tonmeistertagung. And these cards were lying around here everywhere. And in this way, I found the sponsors to realize the project I'm going to show you today. First of all, the topics of this presentation. I'm going to give you a short introduction to the project's idea. Afterwards, we'll have a little look at the technical realization of the project. And then I'm going to tell you something about the first user experience with the platform HOERSPIEL. And at last, I'll give you an outlook on the project's next steps. And we will have time to discuss the results if you would like to. First of all, computer games have become a very important element of global culture during the last years. Due to this, it's getting more important to provide barrier-free accessibility, as we know that from web applications. Because today, visually handicapped kids, they play computer games which sighted kids play as well, but they play them just with hearing their stereo setup. And they try to play car racing games just by hearing, and that's more like trial and error gaming. Modern technology as surround setups can solve this gap and can help to bridge this gap. And that was the initial idea for me to start this project as a diploma project. But when I started the project and continued working, I found out that the idea to play games just based on sound and to interact with sound is nothing which is only interesting for visually handicapped people. It's also a very interesting game concept for sighted people as well. And so it has become an open platform for everybody who is interested in playing with sound, is interested in new game concepts and new man-machine communication concepts. So I'm going to show you the way of technical realization for the project now. To support an application just based on sound, it was necessary to build a special environment for this. I'll call this environment event room later on. So that's just the name of the installation you will see next. These special event rooms should be optimized for the application's target and support it with a defined acoustic characteristic and a special controlling interface. The interface will be called floor interface. You will understand that later on. Furthermore, the room should be completely sealed off from light. It should be completely dark inside so that the user's recognition focus on sound. And to enforce this impression, it was also necessary that the user loses orientation in the room. That's done with a completely dark room, but I have another few steps to get the user lost of his orientation in the real room. So he needs to orientate in an acoustic world. Within the limit of a budget, it was necessary to set up this project mainly on consumer technology And also it was necessary to find some very creative technical solutions to realize this project. You will see that later on as well. And to give you a short impression on the realization phase, I prepared a short making of video. It's just a minute and you will get a short impression. So I think now you understand I'm not talking about software, I'm talking about real hardware. And that's a picture of the realized event room. And you see a bit of the speaker system. And I'm going to explain you the components of the platform now. First of all, the multi-channel sound system. As I said, it was necessary to set up the platform on consumer technology, and therefore there were only 3 options to set up the multi-channel sound system. I could choose between 5.x, 6.x, or 7.x systems, because these systems can be driven by state-of-the-art sound cards using the DirectX programming interface with all its features for 3D sound, which I needed. The decision for using a multi-channel system based on 6.x was rooted in the symmetrical setup which can be realized with this configuration. As a platform should support a high degree of interactivity, which is one of the main quality reasons for a good game, it was necessary that we have no access in sound, so that the user loses his orientation, as I said at the beginning. So we didn't have a sound access like we know that from cinematic systems, but we had a completely symmetric setup. Due to this fact that the quality of computer games is linked to their grade of interactivity, HOERSPIEL should provide a maximum grade of interaction. In adventure games, as I said, one indicator for interactivity is the independence of the user's movement directions. This aspect, combined with the consideration that discrete sound signals are easier to locate in the room than virtual sources, led to the decision that the main movement directions in software should correspond to the positions of the sound sources in the event room. As creating virtual worlds is easier with taking symmetric shapes like hexagonal elements, the decision was reached to set up HOERSPIEL on a 6.x system. To realize this setup, a few components were available, 6 full-range speakers, you've seen them before, and 3 full-range, 3 stereo amplifiers. The low cut-off frequency, as you can see in this figure, is around 70 Hertz, and this is not very low, but it's enough because in the dimension of this room, the small dimensions, it even wasn't, we weren't able to produce low frequencies. So the bass response was affected negatively anyway. And to interact with sound objects, the focus had to lie on a good localization of sound objects, and as described before, the use of discrete signals. Therefore, the beam width of the speakers were more important, and as you can see in the right figure, this beam width was good enough for the application. Here you see a rendering of the room where you can see it from top without the roof. And the specification of a symmetric 6-point-X system and its correspondence to the virtual world led to this construction this I set it up, the event room, in an hexagonal base area. Each wall of this room had one speaker, as you can see, at a height of 1.65 meters, which is an average height of the ear. As I said before, the room was completely sealed off from light to focus the user's attention on the acoustic scenery. The symmetric architecture supported this focus because there was no point of reference in the room, so the only orientation a user can have has to be the acoustic scenery. The special floor interface was designed to detect the user's position within the room so he can control applications by moving around. And for this, the floor was divided into 14 sectors. You can see them here. All these elements are one sector of the floor, which is pressure sensitive. And here you see now what is meant with creative technical solutions. To make these fields pressure sensitive, I had to realize a system. And for this system, I used bouncy balls between two contact sheets, and the bouncy balls lifted the upper sheet, and there was a contact in between. And when someone steps on the upper sheet, it's pressed down and the contact is closed. And this signal is then routed to another creative solution, which is this lovely interface. It's taken out of a keyboard interface from a computer's keyboard, and it just puts the signals into the computer. And to give the user a required minimum of orientation, it was necessary to build the floor sloping towards the center. As you can see here, it's not good to see because everything is black. There was a black carpet on the floor. But perhaps you can see it slopes towards the middle. And this is necessary to mark the 0 point of the application, because every action in an application is started from the middle. So the users mostly are standing in the middle and starting actions from there. For example, if they want to go in a certain direction, they just go from the middle into that direction, and when they finished this application and the avatar moved to the point they wanted to go, then they go back to the middle. Here you see the floor interface in the final setup. As you can see, all elements were set up that they could be taken out of the floor to fix something if something is broken during setup. And a next component in the room was a night shot camera that was mainly for security reasons, so that the administrator from outside could see if everything's well inside. And this camera was supported with 5 infrared clusters, but it's still completely dark inside for the user. The symmetric shape of this room caused a lot of problems in room acoustics, as you can imagine. There were 3 pairs of parallel walls, and they are producing a very, very high rate of stationary waves beginning at 57.17 Hertz. Without modifications in room acoustic, the sound characteristics were terrible, especially in the center point where the user is standing most of the time, because in this center point, all of the stationary waves interfered. So I took 4 centimeter thick foam of melamine resin and put it on the wall, and afterwards the acoustics were much better and were good enough for the application. This foam provides an absorption of 90% for a frequency above 1500 Hertz, and that's especially the range which is important for localization of sound objects. Further optimizations were achieved in the system itself. So, for example, I tried to avoid low frequencies altogether as far as it was possible. And the rate of decorrelation between the speakers should also be as high as possible. After setting up the hardware, it was necessary to produce a software to run this platform. I programmed a game engine in Visual Basic.NET and DirectX. The following figure shows how complex virtual worlds can be set up with a basic shape of hexagonal elements. Each of these elements can be fitted with its own sound, and also each element can be can get a special interaction. So if the user moves his avatar on one of these fields, a special action is started. For example, he's starting to talk to a person who was standing there. This basic engine enables us to produce lots of various applications. Apart from adventures, for example, it could be possible to produce quiz games where the answers are standing in the room and I have to go to the right answer. Or we also could produce sound databases where we can walk through the sound samples and access a special sound interface, special sound information just with stepping on this sound. And even acoustic jump and runs are possible to realize on this platform, and lots of applications more. Here you see the output for the administrator of the room. That's what he sees when the room is in action. And that's just the base area, the floor interface, and its status, so he can see where the person is standing at the moment. And if that's a different position than the one he sees on the night shot camera, there must be something wrong. I'm going to tell you now something about the first user experiences I could collect with this platform. The first chance for that was the Diploma Colloquium in March 2007. And HOERSPIEL was presented on the Hamburg Night of Science in June 2007 as well. And on both events, it was demonstrated that the considerations were right. Interacting with sound objects and playing acoustic games was something completely new to all players. And it was quite interesting for all the visitors to do that, and they had a lot of fun. But also it was, I could see that it's very difficult for users to interact with sound because it's so unusual to them. And to countervail the biggest problems, I produced a little qualification game which came into operation at Hamburg Night of Science. And this very simple game was just to check if the person is able to locate sound. And it also helped the person to get in touch with the platform. And I've got another short video to show you this. That was taken at the Diploma Colloquium. It's a picture of the night shot camera, so it's very dark and you can't see much. But you will hear the sound as well, and that's this qualification game where the user hears a series of sound from different directions, and he has to follow these directions afterwards. And you also, in the end of this short video, you will see how the platform explains everything to the user. In this sample, it's how to find the exit in a dark room. So I'm sorry for the bad sound quality. That's just the quality of this night shot camera. And you will hear myself and other people talking in the background because we were standing outside the room. But I think it's enough to understand what the platform is like.
Das war leider die falsche Richtung und kostet Sie einen Punkt. Sie haben noch 3 Punkte. Hier eine neue Tonfolge, mit der Sie es noch einmal versuchen können. Möchten Sie Hörspiel wirklich verlassen? Wenn ja, bleiben Sie einen Moment auf dem äußeren Ring stehen. Ich führe Sie gleich zum Ausgang. Falls Sie Hörspiel aber nicht verlassen möchten, gehen Sie bitte zurück zum Basisfeld. Sie hören mich jetzt aus Richtung des Ausgangs. Bitte tasten Sie sich an der Wand entlang zu mir. Und Stopp. Sie befinden sich jetzt unmittelbar vor der Tür. Bitte ziehen Sie die Tür nach innen auf. Ich hoffe, Sie hatten Spaß mit Hörspiel und sage Tschüss bis zum nächsten Mal.
So that was a good example as well, that you can see the room is completely dark inside, and that's very strange for some users as well. That was a bit scaring for some users. That was just the overview of this platform HOERSPIEL, and I'd like to give you a short outlook on the next steps, and I'd like to summarize the results. HOERSPIEL was designed as an experimental project. The goal was generally to first demonstrate that the merit of the idea of playing with sound and creating virtual acoustic worlds is possible. The project showed that this gaming concept can find resonance in the player's community and is fun to play. However, most users would need to get first accustomed to this extraordinary contact with sound. As described before, HOERSPIEL had to be created on basis of consumer technology. So professional systems might produce a higher quality in sound and as well a better resolution in the tracking system. But using consumer technology was also a benefit for the project, because on this way it showed that sound could play a bigger role on even standard computer systems, and not only these supporting roles to support the visual impression of a computer game. The HOERSPIEL environment supports applications with the defined acoustic of a known room, and applications can be built around these specifications. To recreate this, for example, for the consumer market, it would be necessary to set up standards like the special speaker setup and to establish these standards, and we all know how difficult this is. As the technical process is bringing more and more surround systems to the computers and the gamers at home, this idea might likely grow. And the completed project is, as you have seen, already working, and it can be used as a prototype for further development. There's still a high capability for creative applications such as innovative computer games, sound database browsers, or special events at exhibitions or for museums, for example. Here in museums, for example, HOERSPIEL could provide an additional level of information and work as a gate for visually handicapped people to explore this information. And that's basically what I wanted to show you today, and I thank you for your attention. And if you've got questions in English or in German, you are welcome to ask.